Hari Om. Good morning, students. In last class we have discussed the radius is perpendicular to the tangent at the point of contact, and also we have proved that theorem, and also I said that two important corollaries, that is we can draw only one tangent at any point on the circumference of a circle, and also I said that the perpendicular to the tangent at the point of contact is passes through the center of the circle. These are the two corollaries and the theorem that we have discussed in the last class. Now we are going to discuss very important concept, that is tangent from the external point to a circle. Here I will take a circle. With center O. Here I have taken a circle with center O. And I will take an external point to this circle is A. Your point A is the external point and O is here, O is the center of the circle. Now I will draw tangents to this circle. So how many tangents that we can have to draw from the external point? From this external point A, I can able to draw two tangents. We can draw only two tangents. This is the one of the point of contact is P, and this is the another point of contact is Q. Therefore, PAP and AQ are the two tangents that we can able to draw from the external point to a circle. Is it clear, friends? We can draw only two tangents from the external point. And now we can write that O is the center of circle. Again, point A is the external point to a circle. Now, therefore, AP and AQ are two tangents to a circle. So, we can be able to draw only two tangents from this point, external point A. If I want to draw as another start line from the point A, if I draw another line from the A, then it will be passes through the circle, then they will become the secant of the circle. We can be able to draw only two tangents from the external point. Is that clear, friends? Here we easily saw AP and AQ are the two tangents to a circle. Take down this one. And also we have to know one more thing very important is the length of the two tangents to a circle are equal. Here from the O is the center of circle, E is the external point to a circle. AP and AQ are the two tangents to this circle. Then the length of these two tangents are equal. So we can write that here the length of the tangent AP is equal to the length of the tangent AQ. Is that clear, students? The length of the tangent AP is equal to the length of the tangent AQ. Therefore, if we want, we can have to draw to a circle and take an external point and draw two tangents to the circle and measure with the help of the scale. Then the length of the two tangents are equal. Here we can write O is the center of circle. A is the external point of a circle. Then the length of the tangent AP is equal to AQ. Already I said that we can draw only two tangents from the external point of a circle. then the length of the two tangents, from the external point of circle are equal. Therefore, tangent AP is equal to the tangent AQ. If you want, you have to measure from the external point of the tangent are equal. Therefore, easily we conclude that the length of the two tangents from the external point are equal. So easily we can conclude that the length of the two tangents from the external point to a circle are equal. See, here we have discussed two important points. One is we can draw two tangents from the external point to a circle, and second one is the length of the two tangents from the external point are equal. Now we are going to prove this one we can able to prove this one logically using a theorem. The lengths of a tangent drawn from an external point to a circle are equal. Now we are going to prove this one. Now see, this is the theorem 4.2. It's not universal. According to the textbook I have taken, this is the theorem 4.2, and it's very important for 3 marks. It's very important for 3 marks. Now see, based on this statement we need to draw the circle. Based on the statement we need to draw the diagram. See, the length of the tangent drawn from an external point to a circle. So we have to take the circle. See, here I have taken a circle with center O. Again they are given external point. I take A, let A is the external point to a circle. Again, the length of the tangents from one where external point. From A, we need to draw the two tangents. This is the one of the tangent, and this is the another tangent that are named as a point of contact. Here is P, and this is the point of contact is Q. Here AP and AQ are the two tangents. Based on this statement, I draw the circle. See, now we have to write the given. What the given? See, I write the given condition. The given is here. O is the center of circle. O is the center of circle, and AP and AQ are two tangents from the external point A. Here AP and AQ are two tangents from the external point A. This is the given. By the statement we have drawn a diagram. By this we have written the given. Now we have to take the construction or to prove. I should be prove. What I have to prove that? So we have to prove that are equal. Which are equal? Tangent drawn from the external point of circle are equal. That we need to prove that. So here we need to prove that the tangent AB is equal to the tangent AQ. We need to prove that the length of the two tangents from the external point of circle are equal. So we have to prove that the length of AP is equal to the length of the tangent AQ. Now come to the construction. The construction is what here? The construction, we have to join OP, OQ, and also it should be joined OQ. OA. Now we have the construction is join OP and OQ. So we need to join. So we need to join OP, OQ and OA. And also we need to join OP, OQ and OA. We need to join these terms. Now we have to come to the, after this construction, come to the proof. It's a very simple proof. It's very simple proof for 3 marks and very compulsory for the exam. See, come to the proof. We have to take the 2 triangles. One is OPA. OQA. We will take the 2 triangles. Now we have to take the 2 triangles. We have the 2 right angle triangles. We have that is triangle OPA, and we have to take OPA is one triangle, OQA and triangle OQA is the 2 triangles. The 2 triangles are taken. Now we can write that. See, we can write that by these 2 triangles easily we can have to prove that first I'll take the length of OP is equal to OQ. See, the length of OP is equal to OQ because the radii of the same circle. Radii of same circle. The radii of the same circle. So we can write the length of OA is equal to OA. We can write. See, in this triangle OA, and also it has triangle also has the common basis what OA. Therefore OA is equal to OA. That is what common side of 2 triangles. See, this is the common side for the 2 triangles. So already we have discussed in the theorem 4.1, that is the radius is perpendicular to the tangent at the point of contact. So here it measures what 90 degree. Here an angle is what 90 degree. We have discussed by the theorem 4.1. The radius is perpendicular to the tangent at the point of contact. Therefore, angle OPA is equal to angle OQA. They are equal to what 90 degree. OPA is equal to OQA. Therefore, here we can easily conclude that the 2 angles are equal. So we can write that by the theorem 4.1. Or also we can write radius is what? Perpendicular to the tangent. Here we can write radius is perpendicular to the tangent at the point of contact. At the point of contact. Therefore, see here 3 terms which are equal. Easily we can conclude that these 2 triangles are said to be a congruent. We have already discussed in the 9th standard some criteria or postulates. So here by using the RHS postulate, we can easily conclude that the length of the 2 tangents are equal. See, right triangle, this is the right angle, opposite side. The 90 degree opposite side is what we call hypotenuse. Here the 90 degree opposite is hypotenuse. See, 90 degree equal, hypotenuse is equal, and any one of the sides. Therefore, triangle OPA, which is congruent to the triangle OQA, using RHS theorem, RHS postulate. Now, therefore, we can easily conclude that the CT we have the corresponding parts of the 2 congruent triangles are equal. Therefore, the length of AP is equal to AQ. AP is equal to AQ. That is the CP/CT. For every statement, for every statement what you are going to write, for that we must write the reason. It's very important. So, I have taken these two triangles. In these two triangles, I have taken the length of OP is equal to OQ, area of the same circle. OA is equal to OA, common side. Angle OPA is equal to OQA. They are equal to what? 90 degree. Because the radius is what? Perpendicular to the tangent to the point of contact, or by theorem 4.1 that you can write. So therefore, triangle OPA is congruent to the triangle OQA using RHS theorem or RHS postulate. Therefore, easily we can conclude that AP is equal to AQ. That is, the length of the tangent drawn from the external point to the circle are equal. Is that clear, students? Take down this one. You must write this. AP is equal to AQ. That is a CP/CT. Today's homework is prove the lengths of tangent drawn from an external point to a circle are equal. This is what I did the theorem that will be practiced, and it's very important for 3 marks, and it's a compulsory question. So take down this one. Very good, students. Now we are going to discuss about some numerical problems based on the theorems. Now here I have taken first question is, from a point Q, the length of the tangent to a circle is 24 centimeter. They are given the length of the tangent to a circle is 24 centimeter, and the distance of Q, and the distance of Q they are given from the center is 25 centimeter. Find the radius of the circle. We need to find the length of the radius of the circle. Based on this question, we need to draw the diagram. See, here I have taken a circle and they are given. Now they are given the tangent from the point where Q. Here they are given one of the tangent from the point Q. So this is the external point. We have to draw a tangent. Already we know that tangent means a line which touches the circle at one point. Now Q here represented as P. QP is a tangent to this circle, and now the given length is what? 24 centimeter, and the distance of Q. The distance of Q from where? From the center. This is, I'll take the center point as O. Now the distance of Q from the center. So I join OQ is equal to 25 centimeter. The distance between the center point to the circle to the Q is 25 centimeter. Then find the radius. Join OP. I join OP. That is the radius that we need to calculate. With the help of this question, I have drawn a diagram. See, now we need to find the radius OP. Here you can observe that OP is the radius. The radius is what? Perpendicular to the tangent. The radius is perpendicular to the tangent at the point of contact. Here P is the point of contact. So OP is perpendicular to PQ. So OP is perpendicular to PQ. What is the reason? We can write radius is perpendicular to the tangent at the point of contact. Now, therefore, we can write angle OPQ, which is equal to what? 90 degree. When it is perpendicular, it measures an angle 90 degree. Now, I take the right angle triangle OPQ, in which angle P is equal to 90 degree. Now OPQ is a right angle triangle. Now we can have to apply the Pythagoras theorem. So according to the Pythagoras theorem, what is the Pythagoras theorem says that in the right angle triangle, square of the hypotenuse is equal to sum of the squares of the other two sides. So which is the hypotenuse here? This is the 90 degree, 90 degree opposite side. That is OQ. OQ square is equal to OP square plus PQ square by Pythagoras theorem. By Pythagoras theorem. Now OQ. What is the length of OQ? Is what 25 square is equal to OP is the radius, we can represent R square plus PQ is what 24 square. We know the value of 25 square is what 625 is equal to R square 24 square. The value of the 24 square is what 576. Now here I'll transfer 576 to the LHS. 625 minus 576 is equal to R square. Now we have to subtract this one. 625 minus 576. If you subtract, you get 49, which is equal to R square. Now square, if you take this side, what it becomes? Square root 49, which is equal to R square. Now we can write R is equal to square root of 7. Your square root cancel. Therefore R is equal to 7 centimeter. Here the square. Now the square root take this side, it becomes square root of 49. So R is equal to 49. We can write 7 square root. We can cancel. R is equal to 7 centimeter. Therefore, radius of circle is equal to 7 centimeter. Is it clear? Take down this one. See students, at the second one. A tangent PQ at a point P of a circle of radius 5 centimeter. Here the radius of the circle is 5 centimeter and PQ is the tangent. Now meets a line through the center O at a point Q, so that OQ is equal to 12 centimeter. Find the length of PQ. See, based on this question, I have to draw a diagram. Here they go. A tangent PQ. PQ is the tangent of a circle. So, here we take the tangent is what? PQ. PQ is a tangent at the point where P. So, here draw a tangent. Here this is the point P and Q. Now PQ is the tangent. PQ is the tangent. And tangent at the point where P. Now, radius is 5 centimeter. Now, the center of the circle are represented by O. Now, radius is what? 5 centimeter. I join OP, which is equal to 5 centimeter. And meets a line through the center O. Next, at a point Q. So, at the point Q, so that OQ is equal to 12 centimeter. OQ 12 centimeter. The length of OQ is equal to what? 12 centimeter. Find the length of PQ. Find the length of PQ. This is what they are given. As we know that OP is perpendicular to PQ. OP is what? Perpendicular to PQ. Why that we have perpendicular? This is the radius is perpendicular to the tangent at the point of contact. That is the reason. Radius is perpendicular to the tangent. Radius is perpendicular to the tangent at the point of contact. The point of contact. Therefore, angle OPQ, which is equal to what? 90 degree. OPQ is equal to 90 degree. Now, I'll take the right angle triangle OPQ, in which angle P is equal to 90 degree. Now, the 90 degree opposite side is what you call hypotenuse. So, we can have to apply the Pythagoras theorem for this right angle triangle. Now, we know the Pythagoras theorem. In a right angle triangle, square of the hypotenuse is equal to the sum of the squares of other two sides. Here 90 degrees P, 90 degree opposite side OQ. Now, we can write square of the hypotenuse OQ square, which is equal to OP square plus PQ square. Square and the hypotenuse is equal to sum of squares of other two sides. Now OQ is equal to 12 square, which is equal to OP 5 square plus PQ square as it is. 12 square value 144, which is equal to 5 square value 25 plus PQ square. Now 144, I transpose 25 to the LHS minus 25, which is equal to PQ square. Now if we subtract, what you will get? Now if we subtract, you will get 144 minus 25 is equal to 119 is equal to PQ square. Now I will take the square this side, then I write here. Therefore, PQ is equal to square root of 119 centimeter. Therefore, the length of PQ is equal to 119 centimeter. Is it done? Take down this one. Now, third question. In the given figure, PT and in the given figure, TP and TQ are two tangent to a circle with center O. Here they given the figure. In the given figure, a circle with center O, and they have given the two tangents PT and TQ from the external point T. These are the two tangents. So that angle POQ is equal to 110 degree. Then find an angle PTQ. Then we find an angle PTQ. Now, see, I'll explain the question again. Here they are given PT and TQ are two tangents and angle POQ 110 degree. Now we'll be find an angle PTQ that we want to be calculate. See, here we know that OP is perpendicular to PT, radius is perpendicular to the tangent. Again, comma, OQ is also perpendicular to QT. This OQ is also perpendicular to QT. Reason we know that this the radius is perpendicular to the tangent. Here the radius is also perpendicular to the tangent. For this too, we can write the reason is radius is perpendicular. Radius is perpendicular to the tangent. Radius is perpendicular to the tangent at the point of contact. Radius is perpendicular to the tangent at the point of contact. Now we know the now we can write angle P is equal to 90 degree and angle Q is also equal to 90 degree. This is the radius is perpendicular to the tangent, therefore it measures an angle 90 degree. OQ is the radius which is perpendicular to the tangent at the point of contact. We know that by the first theorem. Now we know that OPTQ is a quadrilateral. OPTQ is a quadrilateral. We know that the sum of four angles of a quadrilateral is equal to what? 360 degree. We can write angle O plus angle P plus angle T plus angle Q is equal to 360 degree because we use and have derived sum of all angles, all interior angles of a quadrilateral is equal to 360 degree. Now angle O 110 degree, angle P here we have that 90 degree plus angle T will be calculated, should write as it is, plus angle Q 90 degree is equal to what? 360 degree. Now we have to add 90 plus 90, 180 plus 110. We can write angle T plus 270 is equal to 360 degree. So 90 plus 90, 180 plus 110 is equal to 290 is equal to 360. Transpose this one, angle T is equal to 360, 290 that will transpose to the RHS minus 290. Therefore, angle T is equal to, if we subtract, what you will get? So, we have to subtract, we will get the answer is 70 degree. Therefore, we can write angle PTQ is equal to 70 degree. Therefore, we can write angle PTQ is equal to 70 degree. Is it clear? See, this is the radius is perpendicular to the tangent at the point of contact 90 degree. Radius is perpendicular to tangent at the point of contact is 90 degree. Now this term and 110. The sum of four angles of the quadrilateral is equal to 360. 110 plus 90 plus angle T plus angle Q is equal to 90 degree is equal to 360. Now if you add 110, 90, 90, 290 is equal to 360 transfers to RHS. 360 minus 290 we get 70 degree. Therefore angle T is equal to 70. Is it clear? Take down this one.